Hi, welcome to Samsung SDS R&D Cloud. In this video, we will talk about some basic understanding of what is a Docker container and how to build, push, pull, and run a Docker container. Before we get to them, let's talk about what is a Docker. Docker is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software, libraries, and configuration files. Docker can package an application and its dependency in a virtual container that runs on any Linux, Windows, or Mac OS computer. This enables the application to run in a variety of locations such as on-premises, in public clouds, or in a private cloud environment. So coming back to the building a container. To build a container, a Docker file is needed. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. Using Docker file, user can create an automated build that executes several command line instructions in succession. And on this screen here, I have a Docker file already prepared. So let's take a look at what is inside a Docker file. In this simple Docker file, we have we so-called a template here that we use as the base template from Alpine, which is very small and basic. And the next step here is we're actually copying a readme.txt file or text file into a directory called tmp, temp, as just an example. And then next, of course, we're trying to execute a command, basically just cat out the README file that we just copied in. And then last line, it would just keep the container running. Otherwise, the container will say, well, I have executed all your instruction set, and then it will terminate itself. So just to keep the container keep running and alive, this is just another trick that you can do to keep your container running. So in this step here, we're going to show you how to build the Docker container. And in this command, you can see we're starting with the Docker, and then the next one is the build, which we're telling the Docker to build. And the next one is -t, basically give it a temporary name, a tag. So just for now, just for this first step right here, we're going to name it local/docker video and then version 1. Dot stands for all the files inside this directory, and then where the Docker build will access all the files in this directory according to the Docker file. So here we're going to execute this Docker build command. Now you can see actually it separates into a couple steps. As you can see in the Docker file, I have 4 lines, so each steps represent each line right here, and at the end it will say it was built successfully. Along with it's also tagged successfully here with the tag that is given. And of course, after you build, assuming there's no error in this build process, you do want to check out if it actually runs. So I'm going to jump to the next step here. Of course, to test the container, that we just built here, we want to run it. So Docker runs the processes in an isolated container. And a container is actually a process which runs on the host. And the host may be local or remote. So when an operator executes a Docker run, the container actually process that runs in which is isolated in its own file system and its own networking. Basically it's its own virtual process tree separated from the host. So it's pretty safe to run your own program in here. It's not going to interfere or have any conflicts, with other people's things running on the host, or even with other containers running the same host. So here I'm going to demonstrate a simple run command. So first I need to stop my previous one first. Now in this command, you see that the Docker container is, again, it starts with a Docker and then a run parameter here. -D stands for detach, meaning it's coming back to the command prompt, the terminal here. And I gave it a simple nickname. Otherwise, you get a very long hash ID with it, which is a little bit hard to remember. But so I gave it a little bit of a human readable and easy to remember name for my Docker container. And then, of course, this is the tag that I gave it for my build. I'm going to run this container. Now you can see it's actually, it came back with a long hash code here. When you do a Docker PS will give you what are the containers running on your machine, and it will tell you that this particular container with this tag has been running for 44 seconds. Created 44 seconds ago, and it's been up and running for 43 seconds. And this is the little nickname that I gave it. Now to test another way to test it. Now container is running, but did I actually copy the file as shown in the Docker file that I was actually copying a file in here, right here in the temp and readme. So I want to demonstrate that the file actually made it inside the container. So what I did, what I'm doing here is I call again Docker execute -it stand for interactive and terminal, which is going to be allow me to run a command at the end of this parameter right here, and also terminal, meaning come back whatever the result come back would return back to my terminal, and give it my container nickname or name in this case. And when I execute this, I would see my hello world. Now where's the hello world coming from? The hello world is actually coming from the readme file, the readme.txt, where I instructed from, basically I put the instruction in the Docker file to make a copy into the container, and then of course run the cat, but this is inside a container, so obviously it doesn't do any effect when I'm running it from here. But I want to demonstrate that this file did get the copy into the container with the specific location that I gave it. So this is the just a sample unit test that to show that the container is running and is healthy. Now, after test running the container, we will need to give it a proper name for pushing and pulling, of course. As you can see, I was using a temporary name, local slash local slash Docker video, and then of course version 1. So why do we want to give it a proper name? Because this is actually for pushing and of course pulling to a public Docker registry or a Docker repository where it's either hosted in the cloud, in the internet, or it could be a Docker registry that is inside your company infrastructure. So here we will create a tag, the target image that refers to the source image, and then the image name is made up of slash separated name components, optionally prefixed by a registry host name. Well, what does that mean? Well, that means right here that if we want to name retag my container here, the command goes like Docker, and then the next parameter is tag the original old name or the original name that I gave it. Then I gave it the proper name. As you can see, first part of this is actually a URL and a port that is pointing to your registry, your Docker registry or your Docker repository. And then of course the second piece is your repo, your Docker repo name, and then the given tag, which is could be version 1, version 2, so that you can actually keep track of different version of it. In case you have a version 2, version 3, you make some code change in here, so you're not overwriting your existing one. You're not also keep the old version, so you can actually do that by giving a different tag version here or tag name here as a string. Now, once this is properly tagged, Now we can push the container image to the registry. As you can see on the step here, we just tagged it, but we didn't really push it. And pushing is very similar, pretty much similar to the concept of the git push, which is really pushing the container or the code or everything wrapped inside the container, the image, right, the Docker image, to the container registry, where it keeps track of all the containers changes in version. As I mentioned, you can have version 2 and 3. So version 1, you may be, hello world inside the readme.txt. Version 2 could be another file or another script. So you can actually have different versions coexist at the same time. So you don't need to have just one version. So we strongly encourage you to tag it properly. So version 1, you can actually make it explicit where say hello world in this case, or next time we'll be like running a script, you can really put the string or text in there. So when you look at the tag, oh, okay, this is where I was doing the hello world. And the next command, of course, I'm going to demonstrate here is to push the container here, which is pretty straightforward. Again, is Docker, and then followed by the push, the word push, and then the same the Docker tag, the whole tag right here that is given right here. Once you see it's actually since I already pushed it already, so we say it already exists, and you see there's no error coming back. Now, of course, to validate and also to use this container, we will also need to pull the container image from the registry that we just pushed. Pulling the container is pretty much the same. Again, it's the same as git pull, which is pulling the Docker container from the registry, to your Docker engine on your system, similar to here. So which I'm about to show you in a second. And of course, you had to give it the specific Docker container name, the repo name, and the tag, so then you can pull it properly. As you can see, it's actually exactly the same as the previous command, except you just do Docker pull in here, and then give it the whole Docker tag right here. And once you execute it, say, okay, my image is actually up to date. So here, as demonstrated, these commands can be bundled or written into a script or scripts to achieve the build and push in one script or multiple scripts, depending on what you're trying to do. So they can actually be put into a bash script or a build job, a Jenkins build job or Maven or anything that you can actually execute the actual build and the push. With Docker, you can see a user or a developer can write the code inside the Docker container where it can be pulled or used by others as long as they have Docker installed. As I mentioned before, it could be Linux, Windows, or Mac OS. And since all the software libraries, dependencies, and code, anything that you put inside the container, they are the same and always the same when you do the pull. So there's a good old saying, it works over here, so it should work over there. And this is exactly the case. Now, going back to the SRA environment, so what does this Docker do? How does it benefit the SRA environment? Well, the Docker containers can really give the users ability to build and experiment different combinations of their libraries or even versions of their code, along with their code and application or software, anything that they throw inside the Docker container. And once it is tested and validated by the original user or developer, then the container can be used and reused by other users or anybody, which means other people either on your same team or on a different team, they don't need to go through the same installation or experimentation all over again. So this would greatly improve the efficiency among the team members, even across different teams trying to solve similar problems with the libraries and dependency with their code. So thank you. This is the end of the video.